Pull out a single strand of your hair right now. Hold it between your fingers and really look at it. If that strand is gray or white, I want you to stop and pay attention, because what I am about to tell you will completely change the way you see that tiny strand of hair forever. Most people look at a gray hair and think one thing: I am getting old. Some blame their parents, their genes, and their stress levels. But what if I told you that none of those things are the actual reason your hair lost its color? What if the real reason is something so specific, so fixable, that it almost makes you angry nobody ever told you about it? That is exactly what we are going to talk about today, and by the time this video is over, you will understand your own hair at a level that most doctors never even think about. Here is the truth in one sentence, and I want you to really let it land. Your hair turns gray when the cells responsible for producing pigment no longer have the specific nutrients they need to do their job. Not because those cells are dead. Not because your body is broken. Not because aging has made the damage permanent. Those cells are still alive, still sitting inside your hair follicles right now. But they have run out of the raw materials they need to keep working. They are like a factory with the machinery still fully intact and the workers still showing up every day, but the supply chain completely cut off. And the most infuriating part of this entire story is that the three nutrients responsible for keeping that factory running are almost never tested for by your doctor, never discussed by your dermatologist, and never part of the mainstream conversation about hair color. That changes today. Before we talk about the nutrients themselves, I need to take you inside your scalp for a moment, because this is where the real story lives. Every single hair on your head grows out of a tiny structure called a hair follicle, and at the very base of that follicle is something called the hair bulb. Inside that hair bulb, two different types of cells are working side by side every single day. The first type is called keratinocytes. Think of them as the construction crew. They build the actual physical strand of hair using a tough protein called keratin, stacking new cells at the bottom and pushing the strand upward and out through your skin. The second type of cells are called melanocytes, and these are the painters. Their entire job is to produce a pigment called melanin and inject it into the hair strand as it is being built. Every shade of human hair, from the deepest black to the brightest blonde, is determined by the amount and type of melanin those painters inject into each strand during construction. Here is what makes this fascinating and a little bit shocking. Melanin is not something that just sits around waiting to be used. It has to be manufactured from scratch, on demand, every single time, through a complex biochemical process that requires specific ingredients and specific tools. That process starts with an amino acid called tyrosine, which is the raw starting material. A melanocyte takes a molecule of tyrosine and feeds it into a master enzyme called tyrosinase. That enzyme then converts the tyrosine into a chain of compounds that eventually become melanin. Some of that melanin becomes the dark brown and black pigment responsible for most hair colors. Some of it becomes the yellow and red pigment behind blonde and red hair. The exact ratio between those two types of melanin is what gives every person their unique hair color. But here is the critical part that nobody talks about. Tyrosinase cannot do any of this work without very specific helper molecules physically present at its active site. Without those helpers, the enzyme just sits there doing nothing. The machinery is intact, but it cannot run. And those helper molecules depend entirely on the nutrients you eat. Now there is one more piece of this puzzle before we get to the nutrients, and it involves something you have definitely heard of, but probably never connected to your hair. Hydrogen peroxide. Yes, the same liquid in the brown bottle in your medicine cabinet. Your body naturally produces small amounts of hydrogen peroxide as a byproduct of normal cellular metabolism. In healthy tissue, an enzyme called catalase immediately breaks it down into harmless water and oxygen. But in the hair follicles of people with gray hair, something goes wrong. Catalase activity declines with age, while hydrogen peroxide keeps being produced at the same rate or even faster due to rising levels of internal stress on the cells. The result is a slow, steady buildup of hydrogen peroxide right inside the melanocytes, and hydrogen peroxide is a bleaching agent. It is literally bleaching your hair from the inside out, disabling the tyrosinase enzyme, damaging the melanocytes' ability to transfer pigment, and disrupting the signals that tell the cells how much color to produce. A major study published in a leading biochemistry journal documented this process in detail and found that in gray hair follicles, hydrogen peroxide had accumulated to concentrations thousands of times higher than what is found in normally pigmented follicles. The melanocytes were not dead, they were drowning in bleach. What makes this even more urgent is that hydrogen peroxide does not just damage the active melanocytes. It also damages the reserve cells, the melanocyte stem cells, that are supposed to replenish the pigment-producing population at the beginning of each new hair growth cycle. When those reserve cells are damaged, they lose the ability to divide and create new melanocytes. So with each passing hair cycle, fewer and fewer pigment producers make it into the follicle, and the graying becomes more and more visible. But here is the reason this situation is not hopeless. The stem cell damage is being driven by the same oxidative imbalance that is damaging the active melanocytes. If you restore the nutrients that power your body's antioxidant defenses, you can protect both the active cells and the reserves at the same time. The earlier you act, the more stem cells you preserve, and the greater your chances of slowing or even partially reversing the graying process. That is not wishful thinking, that is published science. So let us talk about the first nutrient, and this one might genuinely surprise you. It is copper. Now, when most people think about copper, they think about pipes and pennies. But copper is an essential trace mineral that your body cannot produce on its own, and without it, melanin production is not slowed down. It is biochemically impossible. Remember that master enzyme, tyrosinase? The one that converts tyrosine into melanin? Tyrosinase is a copper-dependent enzyme. Copper atoms physically sit inside the active site of that enzyme and are required for the chemical reaction to happen at all. Without copper present, tyrosinase cannot oxidize tyrosine. The reaction simply does not occur. To use a simple analogy, tyrosinase is the lock, tyrosine is the door you are trying to open, and copper is the key. You can have the finest lock in the world and the most perfectly built door, but without that key, the door stays shut. Copper deficiency means every melanocyte in every follicle on your scalp is holding a useless lock, and no amount of anything else will fix that. Copper also acts as a helper molecule for another enzyme called lysyl oxidase, which is responsible for keeping the connective tissue around your hair follicles strong and well organized. That connective tissue ensures good blood flow to the hair bulb and creates the right environment for melanocytes to function properly. When copper is deficient, that supportive structure weakens, blood flow decreases, and the melanocytes lose their infrastructure. And on top of all that, copper is a key component of superoxide dismutase, one of your body's primary defenses against the reactive molecules that produce hydrogen peroxide in the first place. So a copper deficiency does not just shut down the pigment-producing enzyme directly. It also weakens the antioxidant shield that was supposed to prevent the hydrogen peroxide buildup from happening at all. It is an attack on two fronts simultaneously, and it is happening quietly inside millions of people who have never once had their copper levels tested, because copper is not included in standard blood panels. What makes this worse is that copper deficiency is far more common than most people realize, and it is often being caused by something people are doing with the best of intentions. If you take zinc supplements for immune health, which many people do, you may be unknowingly driving down your copper levels. Zinc and copper compete directly for absorption in the intestine. Too much zinc means not enough copper gets through. Beyond that, modern diets, heavy in processed and refined foods, provide far less copper than diets did even a few decades ago. Because refining strips copper from grains and industrial farming has depleted copper from the soils where our food grows. Certain medications like proton pump inhibitors, commonly prescribed for acid reflux, also reduce copper absorption by making the stomach less acidic. Copper absorbs best in an acidic environment, so anything that reduces stomach acid impairs it. The recommended daily intake for copper is around 900 micrograms, but many researchers who specialize in trace mineral metabolism believe that number is too low for optimal enzyme function, especially for a high-demand enzyme like tyrosinase. Now let us talk about the second nutrient, which is actually a two-part story involving an enzyme and the minerals that power it. The enzyme is catalase, the one responsible for neutralizing hydrogen peroxide inside the hair follicle. Your body manufactures catalase on its own, but it cannot build a functional version of it without adequate iron. Catalase is what biochemists call a heme-containing enzyme, meaning at its core sits an iron atom bound within a heme group, exactly like the iron in hemoglobin in your red blood cells. Without iron in that heme group, catalase is just a shell. It has the shape but none of the function. It cannot break down hydrogen peroxide. And iron deficiency is the single most common nutritional deficiency in the entire world, affecting not just people in developing countries, but a significant portion of people in wealthy nations too, particularly women, older adults, and people who eat little or no red meat. A study published in a leading dermatology journal found that individuals with premature gray hair had measurably lower iron stores than age-matched people who still had their natural hair color. Subclinical iron deficiency, where your stores are low enough to impair enzyme function, but not quite low enough to cause obvious symptoms like anemia, is even more common and almost never diagnosed. The second half of this story involves selenium. Selenium is a trace mineral that your body uses to build a family of protective enzymes called selenoproteins, and the most important one for your hair is called glutathione peroxidase. While catalase handles hydrogen peroxide directly, glutathione peroxidase handles a broader range of damaging compounds and also regenerates glutathione, which is the body's master antioxidant. Think of catalase and glutathione peroxidase as two guards standing at the entrance of your melanocyte. Catalase handles the main threat. Glutathione peroxidase handles everything else and keeps the overall defense system operational. Iron powers the first guard, selenium powers the second. If either one runs low, threats get through. If both are depleted, the melanocyte is overwhelmed from every direction. Selenium also plays a critical role in thyroid function, specifically in the conversion of the thyroid hormone T4 into its biologically active form T3. Hypothyroidism, an underactive thyroid, is one of the most well-established medical causes of premature graying, and selenium deficiency is one of the most common nutritional causes of impaired thyroid function, yet it is rarely checked, even in people being evaluated for thyroid problems. Your thyroid gland contains more selenium per gram of tissue than any other organ in your body, and that is not a coincidence. The third nutrient is one you have probably heard of, but I guarantee the connection to your hair color goes far deeper than anything you have been told. Vitamin B12, also known as cobalamin, is the largest and most structurally complex vitamin in human nutrition, and it is involved in one of the most fundamental processes your cells carry out, replicating DNA. Melanocytes in the hair follicle have a limited lifespan. They do not last forever. At the end of each hair growth cycle, the follicle needs to produce a fresh batch of melanocytes from a pool of stem cells that live in a region called the hair bulge. That replenishment process requires cell division, and cell division requires DNA replication, and DNA replication requires B12. Specifically, B12 is a cofactor for an enzyme called methionine synthase, which is directly linked to the production of one of the 4 nucleotide bases used to build DNA strands. Without adequate B12, the stem cells cannot replicate their DNA properly. Cell division stalls, and with each passing hair cycle, fewer new melanocytes are produced. The color fades, the hair lightens, and eventually the strand grows out completely white because there are simply no melanocytes left to paint it. But B12 damages your hair pigmentation from a second direction as well, and this one involves a molecule called homocysteine. When B12 levels are insufficient, homocysteine builds up in your blood and tissues instead of being properly converted to methionine. Elevated homocysteine is well known as a risk factor for cardiovascular disease, but it also has a direct toxic effect on the hair follicle. As homocysteine accumulates, it releases hydrogen peroxide as a byproduct of its breakdown. So B12 deficiency does not just slow down the production of new melanocytes by disrupting DNA synthesis. It also actively increases the hydrogen peroxide burden inside the follicle, adding more oxidative damage on top of everything else. It is a brutal double hit, attacking both the supply of new melanocytes and the survival of the existing ones at the same time. Research published in the International Journal of Trichology found that B12 deficiency was significantly more common in people with premature graying compared to age-matched people with normal hair color. And a separate study found that in people with documented B12 deficiency, supplementation was associated with partial repigmentation of previously gray hair strands. Gray hair regaining color. That alone should tell you how directly this vitamin is connected to the pigmentation process. B12 deficiency is far more prevalent than most people assume, affecting up to 15% of the general population and rising to over 20% in adults past the age of 60. Now that you understand what your melanocytes actually need and why, let us talk about the 5 specific foods that deliver these nutrients in the most concentrated, most absorbable forms available anywhere in the human diet. The first food is beef liver, and I know that is not what most people want to hear, but stay with me. A single 3-ounce serving of beef liver provides around 14 milligrams of copper, which is roughly 15 times the recommended daily intake, along with approximately 70 micrograms of B12, a meaningful dose of highly bioavailable heme iron, and around 30 micrograms of selenium. In one food, you get all 3 critical nutrients in their most potent, most absorbable forms. If the flavor is a challenge for you, soak the liver in milk for a few hours before cooking to draw out the bitter compounds, or use the hidden liver method. Freeze small chunks and blend them directly into ground beef when making burgers, meatballs, or chili. The liver becomes completely undetectable, but the nutritional impact is enormous. Eating liver just once a week is enough, because B12, copper, and iron are stored in your own liver and released gradually over time. The second food is oysters, and these are nothing short of a nutritional miracle for hair pigmentation. 6 medium oysters provide around 4.8 milligrams of copper, 16 micrograms of B12, 6 milligrams of ham iron, and over 60 micrograms of selenium, covering more than 100% of the daily recommended intake for selenium in a single sitting. Oysters also deliver complete animal protein, which supplies the amino acid tyrosine, the raw starting material for melanin itself, meaning you are getting both the pigment precursor and the copper cofactor that the enzyme needs to process it, all in the same food at the same time. Canned smoked oysters are widely available, inexpensive, and retain virtually all of their mineral and B12 content through the canning process. Keep a few cans in your pantry at all times as your nutritional insurance policy. The third food is wild-caught sardines, which are one of the most underrated foods in existence. A single can provide over 450% of the daily B12 recommendation, meaningful amounts of selenium and iron, and something extra that most people never think about in the context of hair color: coenzyme Q10. Coenzyme Q10 is a fat-soluble antioxidant that supports the energy metabolism inside melanocytes, which are extraordinarily active cells that need a continuous fuel supply to keep producing pigment. Your body's own production of coenzyme Q10 declines with age, and sardines are one of the richest dietary sources available. On top of that, The omega-3 fatty acids in sardines reduce the systemic inflammation that creates a hostile environment around the hair follicle and accelerates the depletion of melanocyte stem cells. Because sardines are small and low on the food chain, they accumulate almost no mercury or heavy metals, making them completely safe to eat 2 to 3 times per week. The fourth food is shite mushrooms, and these are the best plant-based copper source you can find. 1 cup of cooked shiitakes provides around 1.3 milligrams of copper, over 100% of the daily recommended intake, plus significant amounts of selenium and a range of B vitamins that support the metabolic pathways involved in melanin synthesis. Shiitakes also contain a unique compound called lentinin, which reduces systemic inflammation and has been shown to support superoxide dismutase activity, one of the enzymes that prevents hydrogen peroxide from accumulating in the follicle. Dried shiitake mushrooms are even more concentrated than fresh. They store at room temperature for months, rehydrate in 20 minutes in hot water, and are available in bulk at Asian grocery stores for very little money. The soaking liquid itself is rich in nutrients and makes a powerful base for soups and broths. The fifth food is eggs, and while they may be the least exotic item on this list, they are the most practical foundation for everything else. 2 large egg yolks provide copper, B12, selenium, and heme iron all in one package, along with biotin, which supports the metabolism of the sulfur-containing amino acids that influence both keratin structure and melanin distribution inside the hair strand. Egg yolks are also rich in choline, which is needed to maintain the fluid, healthy cell membranes that melanocytes use to transport finished melanin out to the surrounding keratinocytes. Even if the melanocyte is producing pigment perfectly, it needs healthy membranes to deliver it. And eggs contain vitamin D, for which receptors have been found directly on melanocyte stem cells in the hair follicle. Eat 2 to 3 whole eggs daily, soft-boiled or poached to preserve the most nutrients. And never, under any circumstances, throw away the yolk. Everything your melanocytes need from an egg is concentrated in that golden center. The practical rotation is simple. Eggs every single day as your baseline. Sardines 2 to 3 times a week, eaten straight from the can on crackers or tossed into a salad in 5 minutes flat. Shiitake mushrooms 3 to 4 times a week, sautéed as a side or stirred into soups. Beef liver once a week, using whichever method makes it tolerable for you. And oysters once or twice a month, canned or fresh, as your high-dose reset. You do not need to be perfect. You do not need to hit every food every single day. You just need to be consistent most of the time, across most weeks, and give your melanocytes the raw materials they have been quietly running out of. Gray hair is not a verdict. It is a signal. It is your follicles telling you that the supply chain has broken down. Now you know exactly what they need, and more importantly, you know exactly where to find it.